আসসালামু আলাইকুম। আমরা স্টার্ট করছি, অলমোস্ট স্টুডেন্টরা চলে এসেছে। আজকে আমাদের টপিক হলো সিনক্রোস এন্ড রিজলভার। আমি একটা স্লাইড শেয়ার করেছি, আশা করি দেখা যাচ্ছে। আজকে আমরা যে ডিভাইসটা নিয়ে পড়বো সেটা একটা ইলেকট্রিক্যাল মেশিন বা একটা ট্রান্সফরমারের মতো একটা ডিভাইস। তো এর মেইন কাজ হচ্ছে যে অ্যাঙ্গুলার পজিশন ডিটেক্ট করা। এর আগে আমরা বিভিন্ন রকম ডিভাইস সম্পর্কে আলোচনা করেছি। আজকে আমাদের আলোচ্য টপিক হলো সিনক্রোস নিয়ে। তো এটা কিভাবে কাজ করে আমরা এখন দেখব। প্রথমে হলো যে আমরা এখানে একটু দেখে নিই যে ছবিটা যেটা আমরা দেখতে পাচ্ছি এটা হলো আসলে একটা সিনক্রোস ছবি। এটা দেখতে অনেকটা মোটরের মতো, অর্থাৎ দিস ইজ বেসিক্যালি সিনক্রো or synchros. It could be singular or plural. So at first, before go deep through the synchro, we're interested to provide the simple definition of this device or motor. So at first, we have to understand what is synchro. So if we want to define synchro, we can write like this. It's basically an electrical machine or it's a transformer-like device that can detect angular position. So synchro is such type of device which can detect angular position, and this is the schematic of a synchro, and there are two parts of a synchro. So the one is known as transmitter and another is the receiver. তাহলে আমরা জানলাম সিনক্রো এটা কি জিনিস। এটা হচ্ছে এমন এক ধরনের মেশিন বা ডিভাইস যার মাধ্যমে আমরা কি করতে পারি, অ্যাঙ্গুলার পজিশন ডিটেক্ট করতে পারি। তো এটা অনেকটা ট্রান্সফরমার লাইক একটা ডিভাইস, অথবা আমরা যদি বলতে পারি ইন্ডাকশন মোটরের মতো একটা ডিভাইস। তো একটা মোটর বা ট্রান্সফরমার মতো একটা ডিভাইস, আর কাজ হচ্ছে অ্যাঙ্গুলার পজিশন ডিটেক্ট করা। এই হলো আমাদের সিনক্রো। এবার আমরা আসি হলো সিনক্রোর যে কনস্ট্রাকশন সেটার উপর আলোচনা করবো, যে সিনক্রোর মধ্যে কি কি থাকে। এবং আমরা বলেছি যে there are two parts of a synchro, one is transmitter and other is receiver. Transmitter could be write TX, receiver could be write like RX for receiver and TX for transmitter. So this could be write with TX and receiver could be write with RX. Then what is the relationship between TX and RX? We'll discuss this. And in the transmitter side, there is a stator and rotor actually, and the stator are just like around the rotor. Basically, there is a three-phase stator in the transmitter, and the rotor can be of different type. Rotor can consist some coil and winding and magnetic core to form a transmitter. And theoretically, the transmitter and receiver both are similar device. That is, the receiver also has a three-phase stator and a rotor in it. But the purpose is different. The purpose of the transmitter is to collect the information and to pass to the receiver. The purpose of the receiver is to reproduce the angular position. That's it. তাহলে আমরা জানলাম যে একটা রিজলভারের ভিতরে কনস্ট্রাকশনটা কিরকম থাকে এবং এটাতে কি কি ধরনের কাজ করা যায়। তো এখন আমরা যেটা করতে চাচ্ছি, একটা নতুন স্লাইড শেয়ার করে, সেটা হলো নিউ শেয়ারে গিয়ে আমরা স্লাইডে দেখি যে সিনক্রো বা রিজলভারটা আসলে কি। তো এখানে আমরা যেটা দেখেছি সিনক্রো বা রিজলভার, এটা অনেক আর্লি স্টেজে ডেভেলপ হয় এবং এটা অনেক ওয়াইড স্প্রেড অ্যাপ্লিকেশন আছে এবং এটা একটা বহুল ব্যবহৃত একটা ডিভাইস। যদিও ট্রান্সফরমার এবং ইন্ডাকশন মোটরগুলো আরো অনেক আগে আবিষ্কার হয়েছে, সেই তুলনায় যদি এদেরকে আমরা আলোচনা করতে যাই, তাহলে সিঙ্ক্রো বা রিজলভার গুলো তুলনামূলক তাদের থেকে নতুন। এটুকু একটা মাথায় রাখতে হবে আমাদের, সিঙ্ক্রো এবং রিজলভার গুলো তাদের থেকে নতুন। এবার আমরা একটু দেখি যে সিঙ্ক্রোর ভিতরে যে কনস্ট্রাকশনটা আছে, একটু আগে আমরা যে বললাম, আর একটু ইলাবোরেটলি দেখি। তো এখানে একটা থাকে যে স্টেটর থাকে, একটা থাকে রোটর। And the difference between other transformer and electrical motor and synchro is that other electrical motor rotates continuously, but synchro cannot rotate continuously. The synchro usually rotate partially, and the rotor is drawn far away from the stator, but in reality, the center of rotation is located here. And as this is the rotor, a voltage should be applied in the rotor. Here there is V sin omega t. So there should be a voltage source, and it should be connected to the rotor, just like this. So if the supply voltage is V sin omega t, and if it rotates, it means that there is obviously the center of rotation. So if you consider this is the center of rotation, so this rotor aligns with this center of rotation. So actually the rotor and stator are concentric, but for simplicity and for easy understand, so that we can understand easily, it is drawn very far away from the stator, but the axis of this rotor, this point and this point, is concentric. So if you want to draw the actual figure could be like this, and it could be like this. So this is the actual figure, but for simplicity we discuss it in separate place. So this is the construction. And another thing is that the stator consists 3 windings. One is, if we denote 0 here, so there are 3 windings. One is 0s1, this is an winding. One is 0s2, this is another winding, and this is 0s3, this is another winding. So this is a winding, this is another winding, and this is another winding, and these 3 windings are connected just like Y, and these are the 3 terminals. So this is the construction of the synchro. The equivalent circuit of the synchro is like this. So we have to draw the coil just like this, and we have to draw 3 resistances of the armature winding, and this will be the terminal. If we denote it as A, B, and C, so this could be the armature resistance RA or R, whatever. Then this is the 3 reactances or the coils. This is the simplest equivalent circuit diagram of the synchro. And there is a rotor side which should be drawn like this. I'm very sorry that I forgot to draw another thing. The rotor side, the equivalent circuit is like this. There is a source, then there is a resistance, and there is a winding. This is V sin omega. This is just the figure of the resolver. There is V sin omega t, and this is the equivalent circuit diagram of this. And this is the rotor resistance RR, and this is the rotor inductance, which is can write JXR, etc. So this is the complete equivalent circuit diagram of the synchro. Before starting the description, we have to just simplify that the synchro has basically 2 parts. One other is transmitter, that is TX, another is receiver RX, and both have this type of structure. One is the stator, another is the rotor. We have to understand this thing. And the rotor, there is a power supply, there is a voltage source V sin omega t. It is connected to the rotor, and the rotor is free to rotate on the stator. Then the rotor is mounted to an external mechanical arrangement. such like it could be used in weather forecasting, or it could be used in radar, and there are so many applications of this synchro. Suppose this rotor is connected to the radar or any rotating object. So when the rotating object rotates, with the rotation of this rotor, this rotor begins to rotate. So this arrangement supports a rotation of this type of rotor. So these are the construction of the synchro. Now we have to discuss the working principle here. Let's go to the next slide. So this is the working principle I want to explain. So the first thing is that the working principle of WP, there are several steps. In the beginning is step 1. We have to supply Vs or source voltage to the rotor, which is just before we have seen. If we discuss here, so this is the, we can describe working principle using this figure. So at first we have to apply Vs to rotor R, where the voltage would be V sin omega t. This is the supply voltage of the rotor. Then the rotor, as the rotor is rotating, there should be some brush and slip ring arrangement to the terminal of R1 and R2, so that the power can be supplied continuously. Or it can be just like an induction motor. So this, there will be two type of arrangement. It could be connected with brush or commutator, or it could be connected otherwise. So first thing, we have to supply the rotor Vs, that is V sin rotor. The first thing. The second thing is that as the sinusoidal voltage is supplied to the rotor, as the current is positive, in the positive half cycle the current is positive, and in the negative half cycle the current is negative, or a sinusoidal wave. Therefore the current begins to flow in forward direction for the first half cycle, and the current flows in backward direction for the other half cycle. That makes change in the north pole and south pole in the coil. That results change in the flux, rate of change of flux, that is d phi by dt or ddt of phi. So this is changed actually. As this is changed, so what is happened? That is, we know that the induced voltage E is proportional to n d phi by dt, where n is the number of winding here and here, and there should be a turn number ratio n1 is to n2, whatever. It is proportional to the turn number. The more the turn number, the more the induced voltage. Therefore, the voltage is induced to the stator, and the stator is connected to the next transmitter Tx. And this is, we have to explain it differently. So now come to the point. If we connect a voltmeter here, suppose if we connect a voltmeter throughout S1 and S2, then what will we get? Actually, there would be a voltage induced here, and if we connect another voltmeter to S1 and S3, then another voltmeter is connected to S3 and S2, so we will get three voltages then. So S1 to S3 indicates this S1 and this is S3. A voltmeter is connected to S1 and S3, and this is the rating of the voltage V. So this is, you can consider it V1. Okay, if you denote that S1 and S2 is V1, it could be V1, no problem. You can rename them according to your opinion. There is no hard and fast rule which one is V1. So we can assume that S1 and S3 could be V1. So V1 can be defined the voltage between S1 and S2. Then another voltage V2, it can be defined from S2 and S3. and another voltage V3, it could be defined within S3 and S1. So if you follow the convention, we can write like so: S1 to S2, this could be V1. Then S2 to S3, this could be V2. S2 to S1, it could be V3. So we now get V1, V2, and V3. So these three voltages are induced in the stator side because of the rate of change of flux produced. So if the rotor rotates around its axis, there would be a flux cut in the stator, and according to the Faraday's law of electromagnetic induction, the induced voltage will be obtained from this terminal. This is as simple as it is. Then if the supply voltage is V sin omega t, so in every case, the V sin omega t is the common. So V sin omega t, and this V sin omega t, and this V sin omega t is common for the three voltage because this is the supply voltage, which we can simply write this is Vs. If we replace the V sin omega t with Vs, then we will get what we will get. Then V3 is equal to Vs then sin theta. Okay. So what is the difference between this theta and this theta? There is you know that omega t is equal to theta. We know that theta by t is equal to omega, and that is why omega is equal to theta t. Sorry, theta equal to omega t. From this equation we get like this and omega t. So here, sorry, this is omega and t. So here we see omega t, omega t, omega t. It means that this is actually theta, nothing else. But this theta and this theta are different. One theta comes from here. That is, if we change the frequency here, it relates the frequency and time period t. The frequency and time period of this supply voltage, it is related to this omega t, and the second one, the theta relates to the angular displacement theta. This theta comes from the angular displacement. So this theta is considered as angular displacement of the resolver. Sorry, synchro. Let's have a look at this figure and try to understand this very deeply. And this is actually very easy thing to understand, but I suggest you to have a look at this slide. Few seconds more. Then, if you there is no question in this slide, we can move to the next slide. That is, we have to understand how does it work actually. It's slightly different from the other motor and generator or transformer or whatever. Is there any question from the slide? If you have any question, please ask me, because this slide is very important to understand the rest part of today's class. Okay, I understood that it is clear to you, because no one is asking any question. So you can make clear the slide and we can proceed to the next. This is actually the total arrangement of the synchro. How does it work? We can understand its working principle from here. We have just described the working principle of synchro transmitter, not the whole arrangement. We have now discussed only the synchro transmitter. So let's discuss the rest part. So there are two parts. One is mechanical part, which is seen here. This is mechanical part, this is another mechanical part, and this is another mechanical part. And we have to differentiate the mechanical part and electrical part by using different colors, just like we can use either pink color, or we can use pink color here to represent the rest of the part. Just have a look. The red color indicates the mechanical connection, and the pink one represents the electrical connection. What I am drawing is, it represents the transmitter part. Now I am drawing the receiver part. Now the receiver part is completed, and we have to understand which one represents which thing, and we have to make a barrier between the transmitter and receiver with a wall. Let me draw. This is a barrier, and it is in between the transmitter and receiver. Okay, now I have drawn. Just try to understand that. How does it work actually? So this yellow line represents a barrier, just like if we use a ceiling, and if we consider this is a control unit or home, then there should be a transmitter just on the roof. And if it is a transmitter, that is, a device should be connected here, just like this, with the flag. In the previous slide, we have shown that is there could be a weather station here, and if the air flows like this, or if we can use different color, the airflow we can use another color. So if the airflow is indicated by this color, and if the direction of airflow is like this, there is a flag which is connected to the shaft of the synchro transmitter, as located here. So when the direction of air is changed, as the flag is mounted to the synchro transmitter with the shaft, therefore when the direction of air is changed, it rotates the shaft of this transmitter with some mechanical arrangement shown here. So this is the mechanical arrangement, and this is the moving object, and this is the pinion which is connected to the moving object, and it makes a rotation in the shaft. For this reason, a voltage is created here, as we have declared that this is V1, V2, and V3. V1, V2, and V3. This three-phase voltage actually passes to the receiver, and this pink color represents the electrical linkage from the transmitter up to the wall. Then the rest of the part is drawn with, that is, orange color to identify it as synchro receivers, and the red color represents the mechanical linkages, whereas the other color represents electrical linkages. Electrical linkage means the electrical power is transmitted and received from here, but there is no mechanical power transmitted from this terminal to this terminal. From this terminal to this terminal, electrical power will be transmitted, and mechanical power is remaining in the shaft portion. So how to detect the airflow or wind? So the simplest way is to just observe the receiver indicator or dials. When there is a rotation here, it produces V1, V2, and V3 according to the Faraday's law of electromagnetic induction defined by ddt of phi. And then the three-phase voltage would be applied to this synchro and this synchro together. Although one synchro can be connected, there must be a transmitter and receiver, and there could be multiple receivers if we use multiple rooms to observe the direction of wind, just like this arrangement. Suppose this is two rooms. One observer just watch this movement, another observer watch this movement to understand in which direction the wind is now flowing. So by this way, the receiver or the observer understand the present situation of the and the direction of air. Similar for the radar and naval weapon, everything. So this voltage would be applied to the stator, which makes rotation of this rotor, and it is connected to another mechanical arrangement, which we have just in the previous slide we have shared the concept using this. Suppose we have just in the first slide we use the synchro application, the remote position indication. It means that just air is now flowing here, and this is the direction of airflow, and this airflow is due to the airflow, the transmitter produces V1, then V2, and V3 here, and this voltage is passed inside the cable, and it is passed to the receiver. So receiver is another. There is another arrangement here by which the receiver, the rotor moves according to the voltage V1, V2, and V3 until their phases are the same. Until the phases are the same means if the stator and rotor deflects from each other, there would be an induced voltage and there should be a phase change. And due to the phase change, there would be some current flow here. And the current flows until the phase of this receiver rotor and this rotor remains the same. It's the same angular position theta and theta for this both. The I will flow when the theta and theta they are in same phase. There, in that case, I will be zero. When the current is zero, actually, then there will be no further movement in the rotor. Will observe there is no further movement in the rotor will be observed. So this is the basic working principle of synchro, that is the way of detection of the direction of airflow or the direction of a radar, whatever. If we replace the arrow with a radar, so what will happen then? The radar will move. It is rotated like this, and here the angular position detection will rotate like this. It represents if the rotation starts from here, to here, then there is a direction that is east, west, north, south. So from the radar, it could be rotated from east to north, then it will provide you that 90-degree angle, then north to west another 90 degree, it means it is 180 degree. And similar from south to east, when it returns back, it will produce totally 360-degree angle. 360-degree angle and 0-degree angle is these are the same. So this is actually the receiver. How does the receiver work? And there is a schematic of this concept here. We can clear all the comments. Now have a look at this figure. What does it mean actually? So it is very simple to understand. Okay, now have a look at the slide. No, not like that. This is I think good. Okay, so how can we apply the concept? So we have to take this arrangement. If we use the color convention just like the previous slide, so we have to use a barrier just like here. There is a barrier, sorry, not like that. There is a barrier in between the transmitter and receiver, because if transmitter and that one part is in the outside of the room, whether it is rooftop, it could be rooftop or outside the room, whatever. So this transmitter and receiver part will be different. So this is the property of this concept. And there is another thing. There is the transmitter produces three-phase voltage, and the rotor should be connected to the same electrical connection, which is basically AC voltage. And we have to apply here just sine omega t, that is we have applied Vs here as we have described in the first slide, that is the V sine omega t should be applied here, where we observe that the frequency is now 60 hertz, whether it could be 50 hertz or 60 hertz, whatever. So it should be connected to a regular source, and this source is AC. So this is Vs, and this is basically AC voltage, and it is connected to the same rotor of this terminal and this terminal. That is the same electrical power is connected to the rotor of the transmitter and the rotor of the receiver together. So this is the basic concept of the synchro. That is how does it work. We have understood right now. It's too easy to understand. Then if you have any question, then you can ask me. I will try to simplify the concept. Okay, so I think it's quite easy for you to understand. Now we have to discuss the remaining part of the synchro, that is the rest part. So what is the concept for the transmitter? As we have connected the same voltage source to the receivers, so this can be drawn just like this. So one is here and another is here, but the same thing could be redrawn with different configuration, just like the right hand part. As we have seen that there is an alternate abbreviated symbols. So this part and this part actually they represent the same thing. Both of them represent synchro actually, but how? Let's get started. Then this is the transmitter and this is the receiver, and we have used S1, S2, and S3 for here. So if we connect these three sources inside the figure, just like this S1, S2, and S3, and if we connect the common voltage source of the rotor, it is drawn inside for the left side figure, but for the right side figure, right hand side figure, it is drawn outside of the figure. That is it is drawn here. But the same voltage source is connected to the R1 and R2. Then the same voltage source is connected to this R1 and R2. So if it is clearly understood that, then we can move to the next slide. That is, this figure and this figure are identical. So what is the explanation of this figure? The explanation is like that. If the phase voltage of R1, R2 and this R1 and this R2 is the same, there is no current will be flow, no current will flow through the terminals of the three-phase terminals. That is I is equal to 0. And the explanation we can provide for this figure by if we connect the same Vs to the rotor of each devices, then the stator there would be a current flow I, but the Tx and Rx remain the same. যতক্ষণ পর্যন্ত Tx এবং Rx টা তারা একই না থাকবে ততক্ষণ পর্যন্ত তারা কারেন্টটা ফ্লো করবে। এবং ফ্লো করার কারণটা আমি বলছিলাম যে ফেজ ডিফারেন্স যেহেতু তৈরি হবে, ফেজ ডিফারেন্স তৈরির কারণে আসলে মূলত তারা কি হবে, তাদের মধ্যে আসলে একটা পাওয়া যাবে। তাহলে আমরা এখন বুঝতে পারছি যে আসলে এটা কিভাবে কাজ করবে। এখন যখন এখানে ট্রান্সমিটারে একটা মুভমেন্ট করা হবে, এখানে যে ট্রান্সমিটারটা দেওয়া আছে, ধরা যাক ট্রান্সমিটারটা এখন এই পজিশনে আছে, অ্যাঙ্গুলার পজিশন। যখন এখানকার ট্রান্সমিটারটা এখান থেকে মুভ করে কোন একটা থিটা ডিগ্রিতে পজিটিভ বা নেগেটিভ দিকে চলে যাবে, যেটা নিউ পজিশনটা আমরা বোঝাচ্ছি এখান থেকে এইদিকে অথবা এদিক থেকে এইদিকে। যখন এখানে একটা মুভমেন্ট তৈরি হবে তখন কি হবে, ইনিশিয়াল স্টেজে কিন্তু এই ট্রান্সমিটারটা মুভ করবে না, রিসিভারটা তখন মুভ করবে না। তাহলে এখানে যখন ট্রান্সমিটারটা মুভ করলাম, রিসিভারটা কিন্তু তখনও কি অবস্থায় হয়ে আছে, তখনও কিন্তু সেটা এই ফেজে হয়ে আছে। এখন তাহলে কি হবে, যেহেতু এই রিসিভারটার ফেজ এবং রিসিভারটার ফেজটা আলাদা, as the phase difference between the transmitter and the receiver side rotor are different, therefore because of the variation in the phase, the current will flow through the terminals. The current flow এই ফেজ ডিফারেন্সটা একই না হবে, কাজেই কি হবে, it will begin to rotate until it reaches to the same angular position, just like this one or this one. So it must meet this actually the position of the transmitter. So that one can confirm that the angular position of the receiver and the angular position of the transmitter is the same for this reason actually. তার মানে সহজ কথা হলো যে যেহেতু এখানে ফেজ ডিফারেন্স পাওয়া গেছিল, এই জন্য আসলে এর মধ্যে কারেন্টটা ফ্লো করছিল, তাই এটা কারণ হয়েছে। এখন এই এক্সপ্রেশনটা যদি আমরা এই ছবিতে দিতে চাই তাহলে কি করতে হবে? As we have drawn differently this figure from the previous figure, then we have to explain that the voltage is connected to the receiver by showing the red color here, and the same receiver is connected also here. So this is for the rotor. So this is for the rotor part. So what is the stator part? The stator part just placed inside the rotor, just to represent them in different way, but the conceptually they are the same actually. So what is the explanation for this? The explanation is like this, like that. So if the rotor of the transmitter is in 0-degree angle, suppose this is the direction of rotation of this receiver, if you can draw with green color here. So if there is any change made here, suppose if it is moved from this place to another place, if we use a pink color or if we use blue color here, you will see that if the rotor is displaced from here to here, and if it produces theta is equal to 60 degrees, so what will happen then? If the theta is equal to 60 degrees, so what will happen then? This 60 degree will impose that same for the rotor. Then there is only the change in the there is only the stator voltage. At first the stator voltage is 0 actually. There will be no voltage if the rotor rotates at angle theta. In that case, due to the rate of change of flux, the voltage will be induced here as 1 S2 and S3, and it depends on the magnitude of Vs here. So this is the initial voltage. Then what will happen then? Because of the angular position theta, it will have an impact of this, as we have discussed that V1, V2 and V3 both are related to the theta. As theta is changed, that is V1, V2 and V3 will be changed, which results that there must be a current flow inside this A, B and C. And this current flow until the receiver reaches to the same position. When the receiver reaches to the same position, what will we get actually? We will get that and there is no phase difference, and there is Vs and Vs is the same. Then the current will be again zero instead of flowing through the S1, S1 prime, whatever. For this reason, when they are in equilibrium position or the same phase, the current will be stopped to flow. কারেন্ট তাহলে কি হয়ে যাবে, সেটা থেমে যাবে। কারেন্ট থেমে গেলে কি হয়ে যাবে, এই ট্রান্সমিটারটা এবং রিসিভারটা তারা কি হয়ে যাবে, ইন ফেজে থাকবে। তো এই হচ্ছে এটার এক্সপ্লেনেশন যে কেন তারা ইন ফেজে থাকবে। Then what are the advantages of this synchro? We have to understand that there are several advantages. So first thing is that the controlling unit can be along distance. So this is the first advantage, that is along distance means from that is outside or from a distant place, we can understand the angular position easily. So this is the first advantage. Then the second point is that this low consumption, as we've seen that there is no load is connected to the synchro resolver, that is why its consumption is quite low. Then the third one is that as it eliminates the necessity of mechanical linkage, we have explained this, we have used a barrier that is inside the room and outside the room. Then electrical connection is established there. There is no mechanical linkage from the inside the room and the outside of the room or the distant place. Only the mechanical linkages are nearby location, just like the rotating object connected to the shaft or the shaft connected to the rotating indicator. That's it. So this is one of the major advantages. Then the continue accurate and visual information. It means that the information is continuous. Continuous means until the phase becomes the same, the rotation continues actually. That it means that it always follow the transmitter. That the receiver indicator.
আমরা কিছু দেখতে পাচ্ছি নাকি?
দেখতে পাচ্ছ না কেন? শেয়ার দিছে যে শেয়ার দেখাচ্ছে, কি দেখা যাচ্ছে?
স্যার বইটা দেখা যাচ্ছে শুধু।
আমি বলছি যে এতক্ষণ আমরা আলোচনা করলাম, তাতে প্রধান সুবিধাগুলো হচ্ছে, এক নাম্বার হলো এটা দূর থেকে কাজ করে, along distance যেটাকে বলা হচ্ছে, the control unit can be along distance from the control unit. It means that it can be worked from a distant place. Then the second advantage is that its power consumption is quite low. Low power consumption is due to the fact that it is not connected to any load actually. That is why as no load is connected to this device, therefore the consumption is quite low. The third one is that it eliminates the necessity of mechanical linkage. So mechanical linkage, we have explained this at this time, that suppose there is a room and outside the room there is a radar or the flag, whatever, and inside the room there is another unit. So these two units are not connected mechanically, they are connected electrically, just like with a cable or wire. They are connected, but they are not connected with mechanical linkage. The mechanical linkage are limited to the nearby devices such as the rotating object to the shaft of the transmitter or the indicator to the shaft of the receiver. That's it. So this is the mechanical linkage. The mechanical linkages are are nearby, and from distant place we just supply the electrical power from the transmitter to receiver. That's it. And another advantage is that the continuous accurate and visual information means the indicator of the receiver always follow the angular position of the transmitter. That is, it always follows the transmitter. That is why it is continuous. Continuous means there is not discrete. That is for instantly the receiver indicator change when there is a angular movement in the transmitter. And visual information means we can visualize the angular position because an indicator, that is an angular indicator theta, we will see north-south is just like this, and east-west. North-south just like we have observed, there is visualized to, and it easily visualized, can understand the direction of wind flow, rotation, anything by simple visualization. So this is the visual information actually, other than a numeric value, suppose 12.5 or 7.6 or so on. This is a numeric and this is a visual, but this information is visual. If we use a compass or something like that, so compass and gyroscope, this is actually the information is visual, and this information is just like the compass or gyroscope, whatever. Then the last one point is that a good reliability and minimum maintenance. It's to understand, to simple to answer, good reliability means it is very robust and it is a strong structure. That is why its reliability is high. And minimum maintenance is that there is no load is connected here, and there is, this is just like a motor or transformer. And that is why we know that their maintenance is not so much. Then another point is that it's small and light. It means that as it doesn't drive any load and consume the low power. Due to low power, it is small and light. You know that all low power devices are small and light. And that last one is that it's very fast. It is very fast means the indicator just show the realistic position or the real-time position. Just it matches with the transmitter instantly. That is why its operation is also very fast. So this is what about the synchro, and the advantages we discussed today, and we have understood how does it rotate, what is the construction, what is the principle, what is the introduction of the definition of this device. We have clearly discussed in the class. So we have understood the whole thing very nice way. And if you have any question, you can ask me. The CR কি কালেক্ট করেছো অ্যাটেন্ডেন্স?
জি স্যার।
আমাকে শেয়ার করে দিও, আর যে কারো কোনো কোশ্চেন থাকে কোশ্চেন করতে পারো তোমরা। তো মনে হচ্ছে এটা সবাই বুঝতে পেরেছো। আসলে কনসেপ্টটা খুবই খুবই সিম্পল, এটা না বোঝার কোনো কারণই নেই। তোমরা অলরেডি পড়ে আসবে কনসেপ্ট গুলো, জাস্ট আমরা একটা অ্যাপ্লিকেশন সাইডে একটু ভিন্নটা দেখালাম। So see you in the next class. Wish you all the best. Take care. Assalamu alaikum.